Hello friends, today we're going to be doing an investigation on balanced and unbalanced forces in addition to friction. So what you're going to need is you're going to need some sandpaper. You can use wax paper, but I did not have wax paper, so I got a Ziploc bag. You need a spring scale. If you have a spring scale, I'm actually going to open mine up to show you. And most likely you do not have one at home, so that's why we're following along. A spring scale measures force, and you're going to have 3 blocks and 3 hooks to go on the blocks. So the first thing that we want to do is put the hooks in the blocks just in the center. We're going to twist those, and this is actually how we are going to be lifting these onto the spring scale. So what we're going to be doing is measuring force with the spring scale. If you remember when we talked about what a spring scale is in the very beginning of the year, we talked about that it measures in newtons and it measures force. And we really haven't been able to use it yet because we were not doing forces. So our measure of force is in newtons with a capital N. And so there's my second one. All right, so we have our 3 hooks. And it says, use a spring scale to lift a block. So the way that we read the spring scale, I'm going to bring some light a little bit closer, is that when we hold it, the force is going to go on to the bottom, and it's going to pull it down with a spring, and wherever it goes down to, like right now I'm pulling it down with 3 newtons of force, is how much force an object goes. So I'm going to pick up this one, and this one has about 1/10 of a newton. 1/10 of a newton, so next one is about 1/2 a newton. And a third block is, it's about 7/10 of a newton. So we're going to take notes of that. The first block was 1/10 of a newton. So I can't turn it sideways because that would not help. So I will tell you it's 1/10 of a newton. The second one was 1/2 a newton. And the next one was 7/10 of a newton. All right, so the next thing that we're going to do is place 1 block. So I'm going to get 1 block. Okay. I'm going to get 1 block, and I'm going to place it on its side on sandpaper. So before we do that, let's think about that this. All right, so the next thing we're going to do is going to have 1 block only, and the sandpaper. Okay. I'm going to attach the spring scale, and I'm going to lay it down on its side. So right now it's at 0, 0 newtons. And I'm going to pull the force that's needed to pull this across. As I pull it, the force goes down to about 4/10 of a newton. Let me try this again here. There we go. As I pull, it gets down to 4/10 of a newton. I did that 3 times, and each time it was 4/10 of a Newton. I'll do it one more time. Oh, that one got up to 5/10 of a Newton. So half of a Newton. All right, and the next one, we're going to do other surfaces. So we're going to see, and now this is rough. This is a very rough surface. Let's go with a smoother surface and see if the amount of force needed is as much. So this is only 1/10 of a Newton. So it requires less force to go over a smoother surface. Now I'm going to add a little vegetable oil. So if you don't have vegetable oil, go ahead and go get it now. Just a little bit. Just barely enough to coat the surface. And I'm just going to put it over a little bit. So this can represent like a slick floor. And we're going to try that here again. And I can feel it's moving so smooth. It's not even going down to 1/10. It went so smoothly. So we're going to do it again. I'm going to move this out of the way here. It's not even going down to 1/10. Again. Oop, that fell, so let's try that again here. I'm trying to pull it in the same way. But I think that my oil ran out. So each time was 1/10. I'm going to flip it over here because we did not do this 3 times. So I got a clean block. And that went to 1/10. That went to 1/10. And that went to 1/10. So each time was 1/10. So when we had the oil, it didn't even move. Didn't really need much force. When we had the block on the smooth surface, it went to 1/10. And when we had the very hard, it went up to 4 5/10. So friction is the force that stops things from moving. The more friction you have on rough surfaces, the more force you're going to need in order to pull it.